Hello, welcome back to the channel. And today we are going to be looking at a new machine, not actually in my collection, it's actually in somebody else's collection, and I'll explain that in a second. It's an interesting machine for me. It's an A3000, an Amiga A3000. And this was a machine that I never actually encountered before. I've seen YouTube videos on it, mainly repairs actually, but I've never physically had one in my possession. I'm only going to have this for a short while because I'm actually going to try and repair it and then hand it back to its owner. It may not actually need repairing. There is some damage to it. You won't be surprised to know if you know anything about these machines. But yeah, it probably will need a little bit of repair. So I'll explain the story behind this. The owner is a guy called Leigh. Leigh has a YouTube channel called, I think it's Noodles Music. And he is Australian, and he is into 8-bit music. He produces SID chip music, which is really cool, something which I'm a big fan of. And also he is an artist. And if you've actually watched any of our videos of the Kickstart events down in Ottershaw, you will have seen Leigh's mini Amigas and mini Commodore computers featured in those videos. I'll link to one of those up above so you can have a watch of that video if you want to get familiar with those machines that he makes. Leigh was chatting to me a while ago at one of these events about a situation that he found himself in where he came into possession of an A3000. So what happened was Leigh was on a trip to Australia to go and visit his family. And during this trip, I'm not quite sure of the details exactly how this came about, but somebody mentioned to him that there was a friend of the family who had a collection of retro machines. Leigh, I don't think, knew exactly what these were. Apparently, you know, he was given the idea that they might be something that he was interested in. So he was asked if he would like to go meet the guy, and so he agreed to go. He ends up traveling to the guy's place, and it turns out that at the back of the property, I think it was, there's a large garage, and the guy took him inside and showed him there was a pit in the floor of the garage, one of those pits that we'd use to do, you know, vehicle inspection from below. But instead of there being a pit there was a staircase that went down. And the guy told him that what he'd done is, many years ago, he'd actually converted that pit into a staircase and then expanded the entire area underneath the garage and turned it into a storeroom. So Leigh went down with him, and lo and behold, the room was absolutely stuffed with retro computers, you know, sort of Aladdin's cave of retro machines. I'm not exactly sure what was in there. Leigh obviously doesn't have a photographic memory, but he did say that there were many, many interesting machines. There were 3 machines or items that caught his attention. There was a monitor, as far as I understand, probably a 1084 or something like that. It was a Commodore monitor, from what I understand. There was a Commodore, the Australian Commodore 64, if you know about that. There was a special case made by a company in Australia. And Leigh has had an ambition to get one of those machines for quite a few years, so that caught his eye. And the other thing that caught his eye was an A3000 sitting on the shelf, looking in pretty good condition, apparently. So he went around and checked and made sure there was nothing else. Now, you've got to bear in mind that Leigh had not gone to Australia with the express purpose of buying anything like this. So I understand his funds weren't amazing at the time, but he did have enough money to make something which he thought was a reasonable offer for the computers. So he made an offer on the monitor, the Commodore 64 and the A3000, and the gentleman accepted. Leigh also told him that, you know, it was an issue with some of these machines that they have batteries in them. The A3000 would be a classic example, and that these batteries can leak and then damage the electronics inside them and actually in some cases destroy them. So although apparently the storage conditions were pretty amazing, apparently it was very dry in there and relatively cool, it's still an issue that the batteries will actually leak. It doesn't really matter about the storage conditions as far as I understand it, unless it was maybe minus 240 Kelvin or something like that. But at normal sort of world temperatures, batteries are going to leak. That's something you can't really stop happening. So anyway, Leigh left with the computer under his arm and I suppose packed it into the car and took the monitor and the Commodore 64 and drove back. Now, what you can see here is the boxed A3000. We have actually had it out of this box. At the Kickstart event where Leigh actually handed this over to me, I did have a look inside, and there is definitely battery damage. As you can imagine, is very, very common with these machines. I'm not really going to go into too much details about the technical specs of this right now. I think what we'll do is we'll unbox it, and then we can start talking about the ins and outs of the machine. It's a very interesting machine, actually, in Commodore's history, a bit of a sort of watershed, you know, a progression in the evolution of the Amiga, but we'll talk about that in a second. But I think what we need to do first is actually get it out of this box. I've got my trusty packing knife. Okay, so since I got this from Leigh, I haven't actually opened it, so I don't know how to open it, but it does say Frontier, and it's actually pretty sturdy. It's made out of some really good cardboard. I'm not sure if it's got styrofoam inside. I pretty much would guarantee that it does, but I think I'm going to cut across here. Using a light touch, of course. I don't want to cause any damage to the packaging, just in case. Well, when I hopefully repair this, I can give it back to Leigh, back in this box. I'm hoping that's going to happen pretty soon, and it's going to be a really happy day for Leigh when he uses this machine. Okay, that's a nice thick piece of cardboard there, really nice stuff. Corrugated, about 1 centimeter thick. Okay, looks like it's in some bubble wrap, so I'm just going to grab it like a handle and pull. Yeah, that's good. Let me push it back so it doesn't fall off the desk. There we go. And let me put this out of the camera for a second. We'll put this down here. Ooh, it's a heavy thing, I'll tell you. A lot of technology inside. Now, this machine, very expensive, but, you know, it was aimed at being a workstation. So, you know, you got what you paid for, basically, back in the day. Looks like it's at 90 degrees. So let's turn that round. So there it is. So I'm going to try and hold this up to the camera. Being careful with it, obviously not to drop it. There we go. That's the machine. Without looking inside, I would say it looks to be in pretty fantastic condition, to be honest. The front of it looks immaculate. There's a little bit of a, well, it's not completely immaculate. There are some chips. There's a little chip there on the front. But overall, I think Leigh must have been very happy when he got this back home. Now, that's all we can really see for now from the outside. Actually, let's have a look at the back as well. Oh yes, that is in very good condition, isn't it? Fantastic. Wow. It looks like this machine is hardly to be used, to be honest. The case feels to me like it's made of metal, and obviously the plastic on the front here. Power switch here, which feels a little bit not super positive, to be honest. I'm not sure if it's got the same design as in the Amiga 4000. I'm not sure if you're aware of that. That has the power button at the front, and then the power supply here, and then you have this plastic rod that goes in between. To be honest, the button on the Amiga 4000 is actually quite positive, so I'm not sure why that's so. Yeah, it's a bit not so great. I think you have room for 2 floppy disk drives in this machine. I think you've got this one and possibly a blanking plate here, so you can put a second one in. Obviously, back in the day, floppy disks were very important. Whenever you got software distributed, they came on floppy disks, so having 1 drive was a must, and very often it made your life a lot easier if you had 2 drives in your machine, because then if you were installing software, you didn't have to constantly swap around disks going into your disk drive. So yeah, I think that's looking pretty encouraging. I think what we'll do next is we're going to take the top off and we're going to have a look inside and see, in quotes, what the damage is. Let's have a look inside and see what we can see. But before we do that, let's have a quick word from our sponsor, PCBWay. PCBWay, where you can make your tech dreams a reality. Right now, PCBWay is holding their 11th anniversary badge design contest. They want you to design a badge that honours PCBWay's 11 years of excellence whilst envisaging a bold and inspiring future. So why don't you take on the challenge? Who knows, you might win some of the top prizes. Whether it's PCB prototyping, PCB assembly, 3D printing, or even CNC machining, PCBWay is the way. Starting with an instant quote for your PCB projects, PCBWay will leap into action, building your PCB, assembling it for you if you wish, and once it's passed their quality tests, it'll be winging its way to you in a flash. PCBWay, PCB prototyping the easy way. Let's get this over there. Wow, it's pretty heavy. Into the work area. And just turn on the light. Okay, let's get this open. Looks like one of the screws is already missing here. Don't know why. Swing it around. Actually, I know there's one in the back that needs to come off as well. So this is very similar to the A2000, I believe, from what I recall. That has 2 screws on the side, and then one on the back here, which just holds the case on there. And let's have a look. Yeah, I think this one here is also involved in holding it on. Let's just open that up. Okay, should hopefully come off. Let's give it a try. I'm not sure if the front here, this plastic piece is actually attached to the front of the machine like with the Amiga 4000, or if it's a part of this case like with the Amiga 2000. Anyway, there's only one way to find out. Oh, there we go. Okay, good. That's good news. This plastic piece is actually attached to this case as one piece, I think. Ooh. Oh. Pretty nasty noises there. There we go. And to answer a question that I asked earlier, there is actually a metal bar here which pushes against what looks like this here. Okay, so it's very similar to the Amiga 4000. The only difference is it uses a metal bar, which to be honest is better. What's weird here is it actually looks like it's a kind of, let me turn that so you can see it better. Almost looks like a keyboard switch, which is quite strange. Yeah, don't know why that has that on there. Maybe it's just easier to turn it on when you're testing out the machine, not sure. Power supply, looks like here we have, what is this? Is this the floppy cable? Oh, looks like it's been disassembled. Okay, that's the floppy cable as far as I can tell. Let's just put that out of the way there. It's a little bit crumpled up, but that's normal. There's a little bag of screws here. I'm guessing Leigh has done this maybe. So let's take this off. Take that out, and yeah, these look like floppy drive screws. Let's just put that together. There we are. So you got the 2 LED on the fronts, the 2 status LEDs. I'm not sure which one of these is the power and which one is the hard drive. Is it possible to see? The left one is power and the right one is hard drive. I'm assuming it will be probably green for power and orange for hard drive. Hopefully you can see this clearly. In here you have the SCSI hard drive. That looks like that is held in place by something. Then you've got the SCSI cable here. You've got some kind of power connector, and you've got the power connector going to the back of here. I'm assuming that is the power still plugged in? No, it's not actually plugged in, it's just there. So it's interesting, the machine's kind of partially disassembled, and I need to fully disassemble it before I can really give you a decent guided tour around the machine. So let's take this off here. This looks like it's a sled on which the floppy drive sits. Actually has 2 screws here, which is a bit weird. What does that do? Okay, so it's a separate floppy drive sled. So we'll just put this out the way over here. We'll put the screw back here actually, because it might be a custom size or something. I'm not sure. It does look a bit smaller than the others. Just put this back here, and I guess this holds down the entire tray, the big tray. So let's take this out. I've never done this before, by the way, an Amiga 2000, so I am feeling my way through this. I'm not quite sure what I'm doing, to be honest. Okay, so does that lift up? Okay, so that's another floppy drive out, and looks like same deal. So those look like they're pretty much interchangeable. So I guess I can put this one back in again. Actually, I wonder if it holds it in. Maybe it holds it in actually. Let's take both of these out. Even though this one has a different size head, I'm assuming that it's actually interchangeable with the other one. Okay, well that's coming up. There's another one here. So far, I am vastly preferring the design of this internally to the Amiga 4000 because that is an absolute beast to take apart. It has this plastic front on it, which is held on with plastic clips. And if you want to take out, for instance, the riser board that you can see here, or if you want to take out, I believe, the drive bay and things like that, you have to take the front off. And some of the clips are down here, very, very difficult to get to. And it's just a poor design. Just makes it really hard to service that machine. And in fact, my Amiga 4000 is broken right now because I was actually reassembling it after putting a CD-ROM drive in. And I had to put the riser card in, and I made a mistake, and I had to completely disassemble the machine. I think it was twice. And unfortunately, the mechanical stress of putting the riser card back in multiple times caused damage to that machine. So that machine's out of service again at the moment. So let's have a look at this. This wants to rise. I've got a plastic thing that goes in here. Put that over here. And there's another one here. So yeah, how do we get this out? There's a screw at the back here. I'm being careful with this case, by the way, to not cut my fingers, just in case there are any sharp edges on it. It's quite easy to slice your fingers sometimes. Take that out. Okay, so this is where it gets, in quotes, fun, where you try and work out what the magic sauce is to actually get this out of the case. Things here that are locking into this. So let me see. Oh, please don't tell me they've done that. Maybe I need to take it back about the design. It looks like they've done something a bit crazy here. It looks like these blanking plates lock into this. So you can't remove this without removing the blanking plates. That would be pretty stupid. Why would you do that? Let's take that out. Put that over here. I guess they had their reasons for it. I guess that's the only place they could put it, maybe. Let's try taking this hard drive caddy out. Maybe that will help me a bit. There we go. Interesting. There is actually a screw here. Maybe that's holding it down. Again, slightly dubious choice if they've done that, but whatever. I guess, you know, you'd have trained people in a factory knowing how to do this, and I'm not one of them, so obviously I have to learn as I go along. I see. There are these plastic pieces on here, and they're trying to hold it from coming out, so I need to lift it vertically, I think. Way, and it's out. Good. So this power supply, I need to have a look at it. So I need to liberate it from this tray here. Let's put it out of the way for a second. I'm going to just put it on the floor here. Okay, there is the machine for the first time. Now we can fully see it. Obviously, I didn't really want to talk to you about it before without opening it up so we can actually see the whole thing. And as I said, I'm not an expert on this. One of the things about working on these machines is that, you know, you learn as you go along. So what can I tell you about this machine? Well, this is the first 32-bit Amiga, native 32-bit Amiga, I should say. The Amiga 2000 could actually run a 68030, but on the actual board itself, it came with a 68000 processor. That meant that internally it was designed as a 16-bit machine, whereas this has been designed as a 32-bit machine. That gets you double the memory bandwidth, and that means that the logic board on here will be based on a 32-bit bus. The Zorro 3 riser that you can see here is also 32-bit, and what that means is any expansions that you plug in here are also going to be able to access that 32-bit bus, which means the machine is inherently faster. There is a 68030 on the machine as standard, and I believe it came with either a 16 megahertz or a 25 megahertz 68030. I'm actually not quite sure where it is on the board. Let me have a quick scan, see if I can spot it. Ah, here it is. MC 68030 FE25. So this is a 25 megahertz version. So well done, Leigh. You've actually got the faster of the two models that you could get. Over here, you've got the memory, which is one of the downsides of this machine is that the memory comes in this weird format, which are harder to get hold of than normal SIMs. So that's one of the advantages of the Amiga 4000. Over here on the 4000, you have a bunch of SIMs. So what else can I say about the Amiga 3000? So the 68030 that you can see here is a fundamentally more sophisticated processor than the 68000. I mean, you can imagine that this is a few years down the line, and Motorola have actually put in quite a few enhancements into this chip. Not only is it 32-bit, but it also has faster integer maths as well. Another thing that this chip also supports is a floating point unit. I'm not sure if one of those is on the board. Normally it would be optional, so you might expect a socket. Not really seeing an empty socket, so it's possible. Ah, here we are. An MC6882. So that's actually the floating point unit for this chip. So that means that this machine, it looks like as standard, came with the FPU. And it says down here, you can either be an MC6881 or a 68882 floating point unit. That floating point unit means if you're doing any floating point maths, this machine runs incredibly fast compared to the 68000, which didn't have any hardware acceleration really for floating point mathematics. It was one of the, I suppose it was a weakness really of the 68000. I mean, it could do floating point maths. It just was incredibly slow compared to this particular CPU. The 68040 that came later, again, much more sophisticated chip, much faster FPU on that. So that's one of the things that you were paying for when you got this machine. When I say paying for, this was, I think it was $3,000, basically somewhere around 3,200, something like that, which works out today in today's money to be about $8,100. So yeah, this was a very expensive machine back in the day. However, let's put it into context. Most machines back in the day were very expensive. Apple Macintoshes also cost $10,000 plus in today's money for their higher end machines, for instance, such as the Quadra 900. I have a Quadra 900 over there, and that was a very expensive machine. So this machine as well, because of its spec and, you know, the 68030 and the various other bits and bobs in this architecture, meant that it was an expensive machine. The Zorro 3 slots here are new to this machine. The Zorro 3 slots are the first expansion slots in the Amiga range that support 32-bit buses. Obviously, you would need that for this machine. So that's a big enhancement on this machine. Another enhancement with this machine was it pioneered, I believe, Amiga OS 2.0, or as I knew it, Workbench. When the Amiga was released, there were certain things about it which in time were changed. That's perfectly normal in business. One of the things, for instance, was that the first Amiga didn't have a code name. It was just called the Amiga. And when Commodore released the Amiga 500, they needed to give the original Amiga some kind of code name to give you an idea where in that whole hierarchy the Amiga 500 was meant to sit. So they called the original Amiga the Amiga 1000, which meant it was meant to be better than the Amiga 500. Honestly, on balance, I think the Amiga 500 was actually more capable. But anyway, Commodore in their wisdom decided to give it that numbering.
And then they also released the Amiga 2000, which was the first big box Amiga. And now, of course, you've got this machine, the Amiga 3000, released in 1990, as I said, for $3,000. So yeah, Amiga OS 2.0, or as I would have called it, Workbench 2.0, was a big leap forward. Had a lot of new features, had a different UI in terms of its general appearance. It was a more monochrome looking UI. And it was honestly a fantastic boost to the operating system. It made it much more professional. From what I remembered, it supported outline fonts and things like that. That meant it was a much more capable machine in general to go along with these enhancements with the 32-bit architecture in this machine. Now, if you were an Amiga 2000 owner, you weren't necessarily left behind. You generally would have an accelerator card in your Amiga 2000, and you would also have largely a 32-bit machine. But there were certain things, for instance, accessing the ROMs, which meant you had to go over the 16-bit bus, and that obviously would have slowed down your Amiga 2000. You didn't have that problem with this Amiga 3000, so this was a much faster machine. Another feature it has here is a flicker fixer, so that you can basically output the image and it doesn't flicker. And it's one of the big features of this machine. The Amiga 4000 weirdly doesn't have that feature. It's in this area, the circuitry, as far as I recall. And that's a bit of a downgrade, really. So, you know, I would say that this is probably the Amiga which was made when Commodore was at its pomp. There were no real compromises on this. Everything was built to a fantastic standard. I think the design of this machine, as I said earlier, is probably the best looking Amiga that they ever made, along with the Amiga 1000. The Amiga 4000, I think, is an attractive machine, but I think this has definitely got the best design. Still a little bit awkward to get it apart, but I guess now that I know that whole trick about, you have to take out the hard drive before you can actually take out the main chassis, is going to make it a lot easier to take apart in future. Okay, well anyway, I think that's enough for an overview of this. I think what we need to do now is we'll have a quick look at the main problem, which is the battery damage here. So this is the damage. And yeah, I mean, on first sight, it's pretty horrendous, isn't it? You look at it and you think, wow, it's pretty bad. But there are actually some really good signs here that I would like to point out. Number one, if you look at the area around here, going around to here, it's pretty hard-edged. What that kind of suggests to me is that this board was sitting flat on a shelf with pretty much no gradient, which is fantastic because the electrolyte has come out and it's gone onto the same spot and it's basically corroded downwards into the board rather than moving across the board. And you may be wondering what's the difference. Well, if you can imagine, if it was sitting on the back of the case where all the ports are on the back, the electrolyte would have flowed in this direction and it would have gone through all of these chips and it would be an absolute disaster area in this area here, going all the way to the back of the machine, possibly damaging the ports on the back of the machine as well. On the flip side, going in this direction, the same thing. Obviously, everything in this area could have been wiped out if it was sitting on its face. I mean, there's not much chance of that, really. Most people who are careful with machines wouldn't actually sit the machine on its face. But a very common scenario, and this is actually what happened with my Amiga 4000, was it was sitting on its side. And in my case, it was sitting on its right side, so the electrolyte flowed in this direction. And I was lucky because it didn't get too far, but it did cause a lot of damage. And obviously, if it had been sitting on its left face, it would have just flowed towards the left of the case and caused damage in that area, which you can see if it had done that, it wouldn't be too bad either. There's only one chip here. I mean, it's one of the main ones, system chips as far as I'm aware. But anyway, damage to one thing is actually better than damage to many, many things, right? The other thing I think to bear in mind is that if the damage is very localized like this, there's a decent chance that actually what got damaged here is the clock circuit. In today's age, we don't really need the clock that much on an Amiga. The reality is that we're not going to be doing day-to-day work on it probably, and that means that dating your files isn't really that much of a necessity anymore. Obviously, it would have been very useful back in the day when you wrote a document to go back and see when you had written it, but these days it's not really that much of an issue. We're mainly using these machines to noodle about with old software, play some games, things like that. So the loss of the clock isn't such a big issue. If you want to be a purist, you can obviously try and reinstate the clock circuit in this area, and we'll see how far I go with it. This piece of metal here is actually one of the ends of the battery, which has been clipped out. I think Leigh did that. And I'm really not sure, if you have a look here, there's this kind of bubbly, clear looking stuff. I'm not sure if that's something that Leigh has done, or if that's actually just the damage of the actual mask put on top. If you look over here, it's reached the base of this resistor. And you can see, luckily it hasn't really gone too far up the legs, I don't think. Have a look at that. No, not really. I'm not seeing too much green on here. It hasn't even got to the, oh, there's a bit of flakiness here. I don't know if you can see that. A bit of flake coming off. If you look over here, it hasn't really got to this leg. But all of the pins in this area look a little bit grey rather than being metallic looking. And that shows you that there is some corrosion on them. If I look on the side of this pin here, I'm assuming there was some vapor from the electrolyte here. It's actually caused some greening on the edges here, but actually not too much. Still, obviously, there's scope for this chip to be damaged, but on this side, it looks a bit worse. I can see some more green on here, definitely. And then over here, I can see a tiny bit of green on the legs here, but again, nothing massive really. This seems to have a bit more. And again, you've got this shiny green stuff here, which is that solder resist? It's actually perished or something? Yeah, it looks like it, doesn't it? If I scrape it with this piece of wood, you can see it's actually coming away, whatever it is. So yeah, we've got a bunch of resistors in this area, and I'll have to do some research into this and try and work out what these are for. I'm not really planning to remove these immediately. I think the first thing we need to do is just get this area clean. I'd like to try and get it to a point where you can see copper here, and remove some of the solder mask in some of these areas and get it back to looking, you know, kind of clean. This area here has some of this flaky stuff. I actually thought it might be the corrosion, but in fact, it's actually just this green stuff that's flaked off and moved over there, which is good. Oh, that's great news. I was worried about that, but turns out it's just this green stuff. I'm assuming it's the solder mask, actually, which is probably, yeah, it's just flaking off, isn't it? Yeah. Very, very fragile. So yeah, I've got a fiberglass pen, and I think the next thing we're going to do is work on that. But before I do that, I'm actually going to, I think, take a look at the power supply first, because I want to try and make sure that the power supply is working. And if it is, if it's looking within spec, then we'll assume that it's going to work for at least a few more weeks or months. And what we'll do is, I think we'll try and test this board, see if it's actually working. Because there's no point in, you know, getting into repairing stuff if you actually don't really know what's actually broken. So I think the first thing we want to do is, like I said, have a look at the power supply, see what's going on there, and if it's looking good, yeah, I think we'll plug it in and we'll give this a go. Okay, well, I'm going to have to move this out of the way. Obviously, it's quite big. Let me just put this over here, out of harm's way, and I've got the chassis down here. Okay, well, that's held on, that plastic. We don't want to lose that. And what we want to have a look at, it's actually trapped, captive in there. It's a bit of a pain. How do I get that out? Oh, there we are. Just squeeze it through. Sometimes we tend to overthink things, I think. Oh, no, that has come off. Okay, let's put that over there. And I'm assuming I'm going to have to just unscrew here. This is very awkward. Okay. And there's one there. I think there's one there. There we go. And are we free from the chassis? We are. Okay, good. Right then, let's put that out of the way. Right then, what does it say on here? 240 volt. Yeah, obviously. Well, actually not obviously. This is for Australia. So I assume that they have 240 volts over there. Good point. Output 5 volts DC, 12 volts DC. So we're looking for a 5-volt rail and 12-volt rail. Tension, blah, 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 blah. Okay, before we plug it in, I would actually like to open it up and have a look inside just to see if there's anything wrong with the caps, which I'm assuming will be absolutely fine, but you never know. Also, something which you could do for the future is to replace this with a Noctua fan just to make it quieter. I'm not sure if Leigh wants to do that, but yeah, that's definitely an option. I've done that in my Amiga 4000, and I think I also did it in my Amiga 2000 as well. Let's take these out. This should hopefully allow me to get the top off. I'm not sure if there's any more screws involved in that. Okay, well, it's not feeling very loose, so let's have a go. Yeah, maybe this one here, actually. Okay, there we go. Okay, what can we see? Dust, to be expected. Big cap here, looking good. It's looking nice and good down there. That's looking clean. I can't see, I mean, I've got to say, it's remarkable how little dust there is inside here. Is this dust? Yeah, it is. It's kind of white dust, but my God, there's hardly anything in here in terms of dust, which is kind of crazy when you think how old this is. This cap looks okay. Not such a big fan of this. This looks like a massive heatsink here. I'm assuming there's some kind of transformer or transistor going on there, I think, and it dissipates its heat through all of this. And underneath it here, there's a big capacitor and another big capacitor. And they both look fine, but not sure it's such a good idea to have this heatsink right next to these. But anyway, that's what Commodore designed. They know a lot more about making power supplies than I do. But down there, the can looks perfectly clean, no bulging, no bulging, no bulging, no bulging. Eyeball inspection, it looks okay. I don't see anything wrong with this. I think what we should do is close this back up and just try a smoke test, just try plugging it in and see what happens when we turn it on. Yeah, I'm assuming that's in, that's off. Okay, so let's, like I said, for safety reasons, let's just put this back together for now. What I'll do is I'll just put 1 or 2 screws. I won't put all of them back in, obviously. Is that enough? Yeah, it is. It's fine. Okay. So, the moment of truth. I've got a power supply over here, I think. Let me have a look. Yeah, I do. This is off, so let's just plug this in. Nothing happened, which is great. Turn it on. Don't know if you can hear that. The fan is running. But as you can see, it does make quite a lot of fan noise, so Leigh may want to consider replacing the fan there with a Noctua. Very simple thing to do. Noctua the right size, just take this one out and wire in the Noctua to replace that one, just to make it a bit quieter. You can also put a resistor in there to slow down the Noctua. I'm assuming this is a 12-volt van, and you might want to knock down the power supply of this to something like 7, so it runs at half the speed. With a modern fan, you probably get the same airflow, and it'll do the job perfectly fine. But anyway, right now it's working great. So let's have a look at the actual power supply itself. Turn that on. Got myself a little diagram here that I've made, prepared, and this corresponds with the plug here. This piece of plastic here that clips it on corresponds with this, so I'll just have to bear in mind the orientation of the two when I do the measurements. But I think we'll start off with the Molexes first and the floppy drive connector, because they're a little bit simpler to test. I checked, and on these, the common or ground is in the center. So it's Check this here. 5.19, that's okay. It's a little bit high, but you know, you usually should test these things under load. So I'm assuming that when it's under load, it'll probably drop a little bit. And then here we've got 11.88. So that looks pretty good. Obviously, I'm assuming that if we check the floppy connectors, we'll get the same thing, but worth checking, I guess, just for a second. Let's look. Yeah, 11.88. Let's just move that out of the way for you. There we are, 11.88 and 5.19, exactly the same as you'd expect. Okay, now for this. So as I said, let me get my diagram and orientate myself correctly. So if this were to plug into here, all of these on this side would be plus 5 volts and the center pins would be ground. So that sounds like an easy place to start. So let's try and get this in the center. A little bit fiddly. I like using the very sharp probes for my multimeter, but the only problem is they can be a bit fiddly sometimes. There we go. Okay, so 4.966, 5.1. Why is that different? It is slightly different. Okay, this one, 5.1, as we saw on the Molex, the same. So I'm assuming this one is ever so slightly different in the way the power supply is delivered. Interesting. Okay, so this one should be -5, -4.99. That looks great. Next one is +5. Pretty much bang on that one. This one is a tick. So this is actually a clock, which is generated by the power supply. And depending on which country you're in and your power supply that you have, it's either going to be 60 hertz or 50 hertz. In the UK, it's 50 hertz. And I'm expecting pretty much a 50% duty cycle. So what I'm trying to say is that if I measure this, I'm expecting it to show about half of 5 volts. In other words, the waveform is going up to 5 volts and down to 0, pretty much 50-50. So you divide it by 2. So anyway, let's see. 2.69. Yeah, pretty much in the middle. This one is -12. Absolutely perfect, that one. And now this one, 11.88. Okay, well, I would say everything there looks pretty good. I couldn't see anything that looked disastrous, so I think we're good to test the board. For that, I'm going to have to replace this television here. I'm going to need a TV with a SCART, and this one only has VGA, so I'll do that. We may as well get the logic board out of the case because it just makes it easier to put on the desk here. So yeah, let's do that. Okay, let's get this out of its case. For that, I'm going to need these nut drivers, which I always think sounds quite funny. Yeah. And also quite tricky to get out. Let's see if this is big enough. No, it's not. What about on the back here? Too big? Okay, so I think I'm going to have to use pliers to get those out, unfortunately, because I don't have any nut drivers which are big in this. Okay, that's working here, so we'll get these out quickly. I'm assuming all of these have to come out, but quite often you find that when you take these out, one or two of them don't actually need to be taken out. They're actually on the logic board itself, and yeah, as I said, you don't need to take them out. Got some smooth nose pliers here, so hopefully these will do the trick. Yeah. That's all the standoffs, I think. Right, there's a few more screws I need to get out. So let's just put this back in here. Get these out. Actually, there's one last standoff here. Any more? No, I think that is the last one. Just looking around for any more screws that I haven't got to. Looks okay. This needs to come out. So red on the right, red on the right. Remember that. I think we're good to go. Actually this, might have to rotate this, I think, to get to this. There are like two floppy drive screws here, if you know what I mean by that. Flat-headed Phillips. There we are. Okay, let's try lifting it. How do I do this? Usually it's a good idea to go from this direction and pull it forward a bit. Okay, I've got it past it. There we go. So I'm just going to put this here for a second. Then move this out of the way. Okay, let's put this flat. Nothing on the underside? No. Nothing metallic under there? No. Right then. Okay, we got the board out. There it is in all its glory. Power connector there. So we're going to have to, I think, orient it this way. And that's so that we can put the PSU here with a cable reaching there. And then we need to get to the monitor connector on here. Which one is that? Oh, pretty difficult to tell now. I'm going to have to look at the back of the case to work that one out. And then we're going to plug it into a monitor here. Okay, got the monitor set up. I've plugged the SCART into the back of it. Obviously, we don't really need audio for now. This is the 31 kilohertz video input for, I guess, VGA class monitors. This is the standard Amiga, the sort of one which comes with all the other machines. So we'll just plug this in here. Got it the right way around. I have. Okay, so we're going to have to put this on here. Will it reach? Well, obviously it'll reach, but the question is, will it rest on here? Yeah, well, actually it'll rest on there. That's okay. And we need the power cable. Get that plugged in. Okay, as I said, the moment of truth. I'll just prop this on here just to keep it flat. So let's see, we've got the monitor plugged in, it's turned on. I believe it's set to the correct input, which is external. I believe that's the SCART input. We've got that plugged in there. I don't think it needs anything else plugged in from what I recall. Amigas will boot without the keyboard, they'll boot without mouse, everything. Obviously they won't boot, but they should at least get to the workbench screen. And if it does get to that, then it shows it's alive. Anyway, I'm procrastinating. Let's do it. Let's turn it on. Fingers crossed. It's a bit noisy. Well, there's some kind of picture, right? Hey, there we go. It's working. 2.0 ROM, so it's expecting Workbench 2.0. As I said, the picture's a bit flickery, so I'm not sure what that's caused by. It could be noise coming from the power supply, although I don't expect it to be honest. Is it vibration? No, don't think so. The other possibility is that this monitor isn't that great. This is another thanks mum for the monitor. This was one of her long-standing monitors. I think this was used by my sister for quite a long time. And I've not used it a lot. I've not actually even cleaned it up yet. I did use it for a quick test with the Commodore 64, and the picture was terrible with the SCART off that. And I think it may have been just the SCART conversion on that particular cable, rather than going for, you know, straight RGB or something like that. Anyway, it's a good sign, right? The machine works. We can see now that it's a 2.0 ROM, which is what I kind of expected. I guess with that in the machine, you could boot up Workbench 1.3 or 2.0, as we said earlier. The next thing we need to do is, can we actually get it to boot? We do have the original hard drive here. And we've got the cable, and we have a Molex. So maybe we should go for bust and try and get that working. I think I can see the SCSI connector. I think it's there. We might be able to get that set up. Let's try and do that. Let's just turn it off. I mean, the chances are that this hard drive, what is it? It's Quantum Pro Drive LPS 1990. This would have been around, I suppose. There's a decent chance that it's dead. But we can give it a try. First off, let's just see if it even spins, which I would expect it to. Let's put it there. And let's try again, turn it on. It's making some kind of noise. Okay, turn that off. Let's leave it spin down. And how do I tell which pin on the SCSI is 0? That's a tricky thing sometimes, because these cables, sometimes like this one, they're not keyed. So let me see if I've got another SCSI cable, which actually is keyed. That might make lives a little bit easier. Yes, I do. I've got this one, which is nice and long, and it's keyed, which is great. There, it's got the notch on it. Actually, from the notch, I can probably tell which way around this one is. Yeah, so the notch would be there, which would mean it's probably plugged in like that, which was, to be honest, my first inclination, because then it would sit like this. So anyway, just in case we have a bit of a boo-boo, let's take this out. There we are. Red on the left. This one actually is keyed, as I said, which makes mistakes pretty much impossible. There we are. Okay. Attempt number 2. Sitting nicely. Just make sure this fan is all good. Yeah, let's turn it on. It's making spinning noises. Yeah, there's a pretty bad flicker there. I really don't know what's causing that. Sounds like it's booting. It is. And it's working. Wow, look at that. It looks really bare bones. So let's have a quick look with the mouse and see if we can see if there's anything in the system folder and in the work folder. Let's just shut that down. As I said, this might be an individual's workbench. I don't know if this has been wiped, so I may blur out the screen if I see anything confidential, and I'll leave it up to Leigh what he does with the contents of this disk. So let me have a quick look if I can find a mouse. Here we go. Got a mouse. It's a bit of a mess, this, isn't it? Oh, it's the usual testing shenanigans. I'm not sure which port the mouse needs to go into, so we'll just try either. Yeah, mouse works now. System, yeah, just a normal system. You know, all the normal Workbench files work. P-page, Scala, yeah, looks like this was used as a working machine. It's got Scala on here, which is a multimedia piece of software. Multimedia was like the predecessor to the web, really. And it's something that I actually was interested in when I was in university. I did my degree sort of project on it, which is pretty interesting. Right then, I don't think we're going to dig any further. As I said, this is private stuff, so but the machine works. I'm absolutely chuffed for Leigh. Fantastic. And it looks like it's fully working. I'm assuming the sound will work as well. I don't think there's anything we can use to test that right now. but I will obviously have to try and get this set up so that I can get data onto it, because I would like to get some testing software on here so I can actually check out and make sure the sound is working and things like that. Anyway, it's a fantastic result. It's better really than I could have expected. So yeah, I think Leigh's going to be absolutely chuffed to see this. So fantastic news for Leigh. The machine is working perfectly fine, isn't it? I must admit this has been a little bit of a drawn out period for Leigh. This was given to me last October to take a look at, but at the time I just wasn't in a good position to do that. I had to put pretty much everything on hold when I also got the cabin ready. The winter was approaching very quickly and I had to get it weather tight. So unfortunately that had to be put on hold, and I explained that to Leigh and he was good enough to understand that. What have we learned in this video? Well, externally, the machine is in fantastic condition. I've got to say, I don't know the name of the gentleman over in Australia, but whoever you are, you did an amazing job of looking after this machine. Obviously, you didn't know about the battery. That's a common thing. People generally don't know about the batteries. But in terms of the environment that it was kept in, it seems to be fantastic because there's no corrosion on it. There's very little dirt on it. I'm not sure how much Leigh obviously cleaned it, but there is some dirt on it. So I'm assuming Leigh hasn't even cleaned it. So it's actually in amazingly good condition. When you go inside, that story continues. The logic board is in fantastic condition. There's basically no dust on it whatsoever. When you go inside the PSU, you find the same thing. There's a very fine layer of white dust. So that suggests that it was just kept very, very clean. Now, obviously there is damage on the left-hand side of the board where the battery-backed clock was. The battery there, I'm assuming it was a Varta, they usually are, has caused a pool of quite thorough damage, but I wouldn't call it extensive damage. It hasn't spread all over the logic board, which is fantastic. Luckily, the machine looks like it was sat on its bottom and didn't have any sort of tilt to it. So the electrolyte has gone there and just stayed in a very tight pool and caused quite deep damage in that area, but it hasn't gone everywhere, which is fantastic. That's why the machine still works, I guess. If you were to think about the future, I would say you need to remove the corrosion there, the green, the copper oxide. That's something I think we'll be doing in the next video, definitely. There's no reason why you want to leave that. And then we'll seal it with something like nail varnish, something like that, just to make sure that no oxygen gets to it so that it can corrode in the future. What else can we say about the machine? Well, we need to test it further. And for that, we need to get some kind of solution to allow us to get data onto it. I could use floppy disks, actually. I do have my Amiga 2000 working, and I could use that as a conduit to get data from my PC. I'm thinking about, diagnostic software. We definitely need to get diagnostic software onto that machine to test it and make sure that, the wires and the sound in it, whatever, is working. Because right now we don't really know that. What else? Well, the display was flickering when we tested it just now. I'm really not sure if it's that monitor because I haven't used that monitor extensively. It's not like my tried and trusted. I do have another monitor over here, which you would have seen in other videos. It's actually currently connected to my Amiga 2000. And the only reason why I didn't try using it yesterday is because it's actually plugged in and it would have been one of those things we have to rummage around under a table. And the other monitor was just easier to unplug and move over there. So yeah, we need to check that the video doesn't have a problem. Is it flickering because of the monitor, or is it flickering because there's some kind of issue with maybe the capacitors? The capacitors in this machine actually look perfect. I've not seen a single one of them that looks bulging, and I've not seen any electrolyte on the board. Even though that's the case, you never know, there could be an issue with the capacitors, but I've got a feeling it's going to turn out to be the screen. But we'll test that in the next video. We'll make sure that which way that problem lies. Should we recap it? Right now, I would probably say no. I don't really see any reason to. It could be that the capacitors in this machine are from before the capacitor plague, which was an issue that arose in the 1990s, more towards the mid-1990s, well, early to mid-1990s, where there were a number of capacitors used in the electronics industry from a new source, and they turned out in the long term to be pretty bad. They worked in the short term, but in the long term, they have a tendency to leak very badly. And because of this, some Amigas and some Macintoshes in particular are affected by it. I've also seen a CD32, it's actually Leigh's CD32. That comes from a little bit later, and that does actually have leaky caps in it. So that CD32 is a newer machine, and yet it's got leaky caps. So that kind of indicates that this machine may come from before the capacitor plague. So it may be okay, those caps could be all right. On the flip side, Leigh may say, you know what, it's not that much money and it will future-proof it to some degree.
let's go ahead and recap it. So I'll discuss this with Leigh and see what he thinks. Should we replace the PSU fan? I would say it's pretty low-hanging fruit. I think we can get an exact replacement for the size of that fan. And it basically has 2 wires. Modern fans usually have 3, the power and control. And you just basically don't use the control and you just use the 2 power cables. So it's a pretty easy replacement. You can calculate a resistor as well to put in series. What that will do is it will drop the voltage down from 12 volts to whatever the resistor is, set at. And that will make it go down to, let's say, 7 volts, and then the fan will run proportionately at that speed. Otherwise, it's going to be running at full tilt all the time. And although Noctuas are pretty quiet, they're not incredibly quiet. So it might be an idea to actually do that, put a fan in there and slow it down a little bit. And I'll discuss that with Leigh as well, if that's something he wants to do. And finally, how are we going to use it in the long term? How is Leigh going to get some use out of it? Well, right now, as we saw, the hard disk is actually working, but I would not say that is a guaranteed thing that's going to carry on happening in the future. I actually had, I think, exactly that model of SCSI hard drive in one of my other machines. I think it was my Amiga 2000. When I got that machine, it had a hard card in it with SCSI drive on it. And that drive actually worked. And it was interesting because I could see there were certain bits of software that the user had on it originally. And I planned to archive some of that stuff. But unfortunately, the drive died about 2 months later. I got it out of storage to work on it again. And the drive in the meantime had gone down the Swanee. So I wouldn't rely on that hard drive. I would replace it, honestly. Now, if Leigh wants me to, I can source a blue SCSI and I can get that set up for him. And I can get it fitted. And so yeah, when I hand it back, the machine will be booting off a blue SCSI. One of the other advantages of a blue SCSI, and you can watch my video on this, there's a bit of a series that I have on blue SCSIs, is that it has this ability to use a Dynaport Wi-Fi. And I'm not sure how well that would work from within the case. It's a metallic case, a bit of a Faraday cage. But I've seen other people do this mod and it actually has worked. And it's basically a free mod anyway. It's a very small increase on the price of I think it's a Raspberry Pi Zero that you have to use. You just have to use the Raspberry Pi Zero with Wi-Fi enabled, that particular model of it, which is a couple of dollars extra. And then you set that up and you possibly get Wi-Fi. It's a little bit hit or miss because it depends on the SCSI controller. Now, obviously the A3000 SCSI controller is quite standard. It's a standard controller with that machine, but I'm not sure it's ever been tested. It was Rob Smith of Rob Smith Devs that actually did get I think it was the driver for that working. So if it didn't work, I could possibly reach out to Rob and see if he's interested in getting it working. Yeah, that's something that we could do in the future. Anyway, this video has been relatively long. I hope you enjoyed it. I certainly did. It was really nice to get my hands on an A3000. One of those machines that's, for many people, a bit of a grail machine. Now, for Leigh, I was just extremely lucky to meet that gentleman over in Australia. And the gentleman was kind enough to give him a good deal on that machine. And, as from what I understand it, Leigh had a good chat with him and explained to him the value of what he had in his storage room there. If you're interested in getting something from that storage room, forget it. The gentleman has since then sold on his stock and has liquefied all of that and got hopefully a nice bank balance from it. And hopefully he's going to use that to have some holidays or maybe pass it on to his grandchildren or something like that. I'm not really sure. But it's really fantastic that those machines went from storage and are now back out in the retro community and being enjoyed by people over in Australia, I would assume. Yeah, so that's it's quite a happy ending to that story, really. Anyway, I hope you enjoyed this video, and if you did, then please click on the like button. Give that like button a stab, a donk, a push, whatever it is you want to do. Because if you don't like this video, it's not going to go anywhere. It's not going to be recommended to anybody. The algorithm likes to see when people like videos, and it can kind of discern that by how long you've watched it for, but it can't tell as well as if you actually click on the like button. That's a pretty 100% way of saying that you liked something. Like this video and help it to grow to other people. If you've never watched my videos before and you'd like to see more, please subscribe to the channel. And if you do subscribe, please make sure you click on the bell, because when you click on the bell, you will be notified about videos from me in the future as they get released. In fact, if you are a subscriber and you haven't clicked on the bell yet, please click on the bell, because I've noticed that we have quite a few subscribers, but out of those, quite a small proportion actually gets notified about our videos. And that means they don't get to watch them. And if you've subscribed, you probably like our videos, so you probably would like to hear about that. Anyway, that being said, I hope to see you again in the next video in this series, where we will move on with the, well, repair and refurbishment of this machine and get it back into Leigh's hands so he can actually start enjoying it. But until then, take care and have a good day.